What typically makes acid-base reactions more unique than other chemical reactions is that the products they make can have acid-base properties. And that allows us to then have an understanding of the ions that are formed and how we can work with those solutions. To further understand properties of acids and bases, we have to look at what are called conjugate acid-base pairs. Now, not all acids or bases fully dissociate in water to form reactive ions. Weak acids and bases only partially dissociate, so they are going to form an equilibrium or reversible reaction. And what happens is the acid, because it's donating a proton, it's going to have an extra lone electron pair that can then be a base to reaccept a proton in the reverse direction. This is important in understanding the strength of acids and bases and how we can predict their properties. So when acids and bases dissociate into water and those ions form, that allows us to understand what properties and strength these compounds have. So let's look at what a conjugate acid-base pair is. If we have H hydrofluoric acid, that's a weak acid. All right, so if we have HF, we know that when it goes into water that it has that proton to donate. So it's going to donate that proton to water. So we have that acid and water is going to be that base. So on the other side, we get this fluorine ion and we get the hydronium ion. When we look at this other side, the fluorine ion has a lone electron pair that can accept that additional hydrogen that the hydronium ion now has. So we can have what's called a conjugate base, because conjugate is what is produced based off its entity, and we have the conjugate acid. Now, how we make these as pairs are HF acid, its conjugate base pair. Because it's the anion that is always going to stay the same, it's just where is the hydrogen. So that is one pairing. Water and hydronium is the other pairing, because where that hydrogen is moving between the hydroxide group, that's really where it's bonding, and those additional hydrogens. Looking below here, we have NH3 and H2O. So NH3 is going to accept, this looks funny, it's going to accept a hydrogen from water, so it's going to become NH4, and water is going to become OH minus. Because water is the one that removed the hydrogen, the hydroxide is its conjugate base because it has that lone electron pair that it can accept the hydrogen back. Whereas our ammonia added that additional hydrogen, so now it has one more hydrogen than in its stable form, that then can donate it back, so we have those two different pairs. So we looked at an acid, and then we've looked at the base and identifying conjugate acid-base pairs. With this, we can then determine the strength of the acid based off how much of the conjugate, conjugate acid or base is present within a solution.